So here we're going to talk about the second law of motion, or Newton's second law, or otherwise just known simply as F equals ma. So let's quickly remind ourselves of Newton's first law, that an object will remain at rest or in constant speed and direction unless acted upon by an unbalanced force or a resultant force. And we said simply that could be remembered as an object would accelerate with resultant forces only. It needs a resultant force to accelerate or deaccelerate. So Newton's second law, F equals ma, is working out, well, okay, if a resultant force causes an object to accelerate, well, how much acceleration is there? So it's a way of quantifying the first law, linking the resultant force to the acceleration. So if we think of the example of a lorry, well, a lorry has a huge engine, it would have a huge driving force, okay? But it's also got a huge mass m. So its acceleration may still be less than a car that's got a much smaller engine, and therefore it's producing a lot smaller driving force, but it's a lot smaller mass. So it depends upon the resultant force, how big the resultant force is. And remember, resultant force is one force. If there's two forces, one force minus the other will give you your resultant force. And the mass is not just one or the other. So what's the equation that links them? It is F equals ma. So F equals ma, where F, very importantly, is the resultant force. So as a quick reminder, we said that was, well, if there's a forward force of 500 newtons here and a backwards force of 200 newtons, the resultant force would be 300 newtons going to the right there. So we need to always remember to work out the resultant force whenever we're using F equals ma. And that's going to be in newtons. We've got the mass of the object that you are accelerating, and that's got to be in kilograms. And then we've got a, the acceleration that it will undergo. And that's in meters per second squared. So if you have zero resultant force, if the forces are balanced, there's zero acceleration. Like we said in our first law, okay, it needs to have a resultant force. So in words, we'll think about what this means. Well, if we rearrange this equation for acceleration, well, that would mean that we need to bring the m down. So it's multiplied there, m times a. If we want a on its own, we would need to get this on the other side, so we would divide. We do the opposite to multiply, so we divide. So we've got F divided by m equals a. So we can see here that acceleration, the acceleration of an object, I should say, is proportional to the resultant force, because we've got F at the top, and inversely proportional to the mass. So if you have a bigger mass, you would be dividing by a bigger number, which would make acceleration go down. So that's why it would be inversely proportional. Whereas if we have a bigger resultant force, that's going to make this number go bigger because we've got a bigger number on the top of our fraction. So let's do a quick example of this. A bike has a forward driving force of 2,400 newtons and a drag of 300 newtons. What is its acceleration if its mass is 600 kilograms? So first thing we're going to do is write down our formula, F equals ma. It's asking us for acceleration, so we need to rearrange. Well, I've got F over m equals a. And now this is where people may rush when they're doing this question, just go, oh, well, the force acting on it is 2,400. Well, no, because F, remember, is the resultant force, not just the force, it's the resultant. So it's got 2,400 and it's got 300 going in the opposite direction. So my resultant force is 2,100, not one minus the other, divided by 600 kilograms. And what's that going to be? That's going to be about 3.5, is it? Yeah, 3.5. So I've got 3.5 meters per second squared there. Let's try and that would be a pretty standard level one. The only thing you can get caught out there really is forgetting to put it into resultant force. Let's try a more tricky one. So same thing before. It's asking us to work out something to do with Newton's second law. So I'm always going to write my formula first. Now it's given me a mass of 350 grams. And you need to spot there that's not in kilograms. So there's 1,000 grams in a kilogram. So and you divide through by 1,000, and that's 0.35 kilograms. It was kicked with a pushing force of 40 newtons, causing it to accelerate at 42.85 meters per second squared. What was the friction on the ball? So I had to think through this question. They seem to have given me F, M, and A there. So you need to think about what you're doing, and you need to remember, oh, well, that pushing force may not be the only force acting on it, because it's talking about friction here. So we need to find a quantity for friction. It may help you to draw, oh, if it's got 40 going that way, and we've got something going backwards that we don't know. So first off, let's work out what the resultant force F is. So we've already converted this to 0.35. So I've got 0.35 times by acceleration is 42.85. So I get that the resultant force F is basically 15 newtons. So is that my final answer? Not quite. That is the resultant force. So that means it's the leftover force that's causing it to move and accelerate in this direction. So I need to think then, well, if F is equal to 15, well, what must the friction have been to give me 15? So it's going to be that the forward force was 40 minus some frictional force, and the leftover force, this resultant force, is 15. So what must that be? It's going to be 25. So I've got 25 newtons equals that frictional force by doing 40 minus 15 and moving the friction over. Now that would be more like a grade 8 question. Next video we'll look at Newton's third law.